Well, hello, boys and girls. Let's get started today. This is going to be a short lecture because I'm going to give you the lab and give you time to start working on that. And this lab is kind of very close to what I did in the lecture last time, code-wise. So I'm not going to be writing code today. I'm going to give you time to write code yourself. But if you need to, go back and watch class 19 where I bring up the code and I go through and write that. But this today, what you're going to be doing is you're going to be writing for Lab 9 several web server programs that essentially serve up web pages. And that means that your server is going to, since it is going to serve things to a browser, you're going to have to follow the HTTP protocol. It's hard to say. So let's quickly review that. And if you want a further in-depth review, again, go back and look at class 19 and rewatch that lecture. Let's quickly go over that. HTTP is based on a client-server architecture where the server, which is what you're going to be writing today, it listens on a port for an incoming connection. It's usually port 80, but in our case, we're going to use, 5454, 1234, whatever you want to use. I suppose if your machine doesn't already have a web server, you could use port 80. But really, since any port is possible, pick a port for your program, run it on there. Now, the sequence that happens on the server, it's going to wait for a connection to come in. It's going to accept that connection. It's going to then read the request from the client, and then it's going to send a response to the client. And that's really the entire transaction. Accept a connection, receive the request, send a response. Especially if we're not dealing with chunked encoding, which there's no reason to do that in this lab. You'll accept the connection, read their request, send a response. And on the client, which you're not going to write the client, you're only going to be writing the server programs for this lab. The client, which is the web browser, is going to initiate the connection, send a request, receive a response. Now, the HTTP request, as a quick thing, this is what's coming from the browser. It has an initial line, which looks usually like get, and then the path to something that you're trying to get, and then the version of HTTP it's trying to get with, and then a set of header lines, and then just a blank line by itself, just a carriage return line feed by itself. Keep in mind, all these other lines have a carriage return line feed at the end of them. So in other words, get, and then carriage return line feed. And then the header lines, carriage return line feed, carriage return line feed, carriage return line feed. And then we have just a blank line, carriage return line feed by itself, and then the message body. Now, on a GET request, the message body is empty, so you're not going to have to worry about that. And primarily for these labs, the only thing you're going to really have to pay for is this initial, or pay attention to, is this initial line. And this initial line, the part that you're going to have to pay attention to is really only this middle part here. So if you look at the GET, and then after the space, it's going to have the path to what it is we're trying to get. That's going to matter for a couple of the programs you need to write here. Now, the response, which is what your program is going to be sending back to the browser, it's going to have an initial line, carriage return line feed at the end of that. And for the most part, your initial line is always going to look like this: HTTP 1.0 space status code 200 space OK, carriage return line feed. And then there are these header lines, which you're probably not going to need for anything we're doing. Maybe you want to include the content length and the content type there, but we don't really necessarily need anything else. And then a blank line, and then the message body, which is what you're going to be sending, your program is going to be sending back. In this case, last class we did hello world. We had that get sent back in this HTML body, and then inside of there, we put this in boldface and put hello world there, /b. You're going to have to do something a little more complicated than that today, but it's going to be close to this, especially for the first program. Okay, so to write that web server, it's basically what we did in class 19, lecture 19. Your server program needs to open a socket, bind the socket to a local address, which in our case for this lab can be 127.0.0.1, which is the local host address, meaning the host of your local machine. If you wanted to run this program, your server on a program, or as a program that could other places on the internet could get to, you could use the IP address of your machine. And if you had a static IP address assigned to your machine, then it would always be there and anybody on the internet could hit that address. with that port and get access to the pages that you're serving up. But in our case, for testing this, just use localhost. Don't worry about having it served across the internet. Just as long as it works. It would also work somewhere else on the internet if you used the non-local host address. All right, so then after you've bound to that socket, we listen on the socket using listen, and then we wait to accept a connection. And if you remember, accept will block. And when accept unblocks, it returns to us the new socket descriptor of the socket for the connection that we communicate on. So after we've accepted, we now have a connection. We then receive the request from the browser. We then formulate our response, and then we send the response in an HTTP format with the initial line, the blank line by itself, and then the message body. And then we close that connection, and then we loop back up to accept more connections. So that's the basic idea of what we're going to do. So let's, now that we've reviewed that, let's jump over and look at the lab assignment sheet. So let me bring that up quickly here. And let me switch over so you can see it. Okay, so here's the lab. And essentially for this lab, you're going to write several programs. There's going to be 3 programs total. And they're going to be as follows. The first one is going to act as a web server that basically just serves up your name. But it's a little bit different than the Hello World example. So you could start with the Hello World example I did last class. But what I'd say is when the user hits that web server from a browser, they should see your name rendered in the middle of the screen in a vibrant color. Now, the vibrant color doesn't have to change. It can be the same color every time, but I don't know, it could be like red or bright blue or whatever you want it to be. So this is very similar to that Hello World example, except that it has to be in the center of the screen and it needs to be in a bright color. So that means you're going to have to figure out how to change the color of the font. And you're also going to have to figure out how to get the text to show up in the center of the screen. And I'm going to let you do some Googling and research that. You might search for something along the lines of HTML centered text screen or window or something like that. But I'll let you figure that out on your own. And then program 2, remember when you go to program 2, make sure you don't just edit program 1 because you're going to have to submit those. So you might want to copy and paste that project and start editing it from there, but just don't accidentally overwrite it. But program 2, what you're going to do is going to act as a random number server. In other words, when the user hits your web server from a browser, they need to put a number in the URL. For example, here, in your case, it might be 127.0.0.1 colon, then whatever port you're listening on, 5454, whatever it is, /100. So that 100 there, that means the server is going to return a random number from 1 to the number we put in the URL there. Now, if no number is given, then the program should return a message saying that they need to provide a number on the URI for that. So in order to do that, you're going to have to figure out how to generate random numbers in C. I'll give you a hint. Look up or Google srand, which is the way you seed the random number generator. You generally want to seed that using the time function. And you're also going to need to call the rand function, which rand, the way it works, it generates a random number between a random integer between 0 and rand max. So you're going to have to figure out how to trim that down to a range 1 and that number. And if you took the systems programming class, you generated random numbers in there. So you should be able to look at your labs from that class, or just do a little bit of Googling to figure out how to generate a random number in C in a given range. And there's tons of resources for that that you'll be able to find. The other thing that you're going to have to do is parse out this. Now, where does that show up? How do we get that number? Well, it turns out that that shows up. Let me switch back to the presentation for just a second here. That shows up on the request as the request comes in. And the place that that request comes in is, let's go back to the request, is here. So when they say they want to get and then /100, it's going to show up right here. So after the get, after that space, you'll have a slash and a 100 there. So you need to figure out how to trim out the part after the slash up to this space, and then you have to try to convert that into a integer. And to give you a quick hint on how you're going to trim that out is, well, how can you find, you want to cut from the first space, or really the first slash. You could basically make a loop that goes through a while loop that goes until it gets to that first slash. And then if we go one character, like a character pointer, so move the character pointer ahead until you get to the first slash, go one thing after that, and then from there up until the next space, that's what we want to treat as a number. And as a hint on how you convert that string into a number, I would suggest you look at using a function called A to I, which is ASCII to integer, or A to L, which is ASCII to long. It can work on just integers. I'm fine with that. It doesn't need to be floats. So look at the A to I function. Essentially what that does is you give it a pointer to a string that has a number in it, and it will convert that for you. There's also another function that you could potentially use for this that might be maybe easier to use, but I'll let you Google both of those. The A to I function is what I used when I solved this, but you could also use scanf, which works like scanf, where you give it a format string. But rather than reading that from the keyboard, it reads the contents from a string. So scanf might be worth looking into, but A to I will also work on that. All right, let's go back to the lab sheet one more time. Okay, so the other part of this that I should mention is the lab, or program 3 in this lab. That's write your program, it acts as a random color source. In other words, whenever you hit that web page, it should serve up a random color. And it should also have the background be that color, but it should have displayed in the middle of the screen, it should have the RGB value of that color. So in this case, the colors range from 0 to 255. So what I want you to do is generate that random color, have the background be that color, and then have it show the red component, green component, and blue component values of that as a string on the page. And this, you can think of this as similar to really parts of the first two. We're generating random numbers like we are in this one, but the range is always 0 to 255. And then we're also displaying some text in the middle of the screen. The only thing that's going to change here is what that text looks like. What's the red, what's the green, what's the blue. And to do that, I would suggest looking at the sprintf function. If you're using C, would be a good choice. It works like printf, but rather than printing to the screen, it prints into a buffer. And then you could display that buffer to show those things. And then how do you change the background color of the entire web page? I'll let you look that up and Google that as well. So when you're done with those three programs, just add them to add the C files, the source files, to a zip file and submit the whole thing all as one thing. Or if you really want to, you could submit the .c files separately for each of these. I assume there'll only be one .c file for each of these. So this would be like, might be lab9.1, lab9.2, lab9.3, or whatever. But just submit all three of those by the due date, which you have a week to work on that, including the time today. And so, like I said, this was going to be a short lecture, and I want you to start working on that. So let me go back to the presentation and go back to where we were. So we were here. We looked at the assignment sheet for Lab 9. So that's all for today. Work on that lab assignment. Don't procrastinate. If you get to work on that, actually the amount of code needed to do those is relatively small. You might have to spend a little bit of time researching, how do I get something centered in the screen? How do I change the font color? How do I generate random numbers? If you didn't remember that from previous classes, you might have to refresh yourself on that. But other than that, it's very similar to what we did in lecture 19, class 19, where I wrote a web server that said hello world and displayed that on the screen. So if you get stuck, go back and watch that part where I go through the code for that in class lecture 19. there's the entire code you need for kind of that web server. And it's really not too dissimilar to what we did with previous TCP/IP programs. It's the same function calls, the same concepts. But watch Lab 19 if you get stuck on the web programming part. And as always, if you have questions or need help, send me a text message, send me an email, and I'll get back to you. And we can set up a Zoom, share screens or whatever if we need to, or I can come down to the university. I'm very close. I can actually see the university from where I'm sitting right now in my conference room here. And there's a cat back there on the windowsill. I don't know if you can see it. But anyway, let me know if you need help. And other than that, work on the lab, and I will see you next time.